All right, I'll draw that. Let's see if it works. Two rays going the opposite direction. Is that what you're picturing?
Yeah.
Anybody else picture something like that? Opposite rays? It's close, but it's not perfect yet. So there's one specific part of this definition that says opposite rays form a line. So you have to start with a point and go that direction. Remember, it takes 2 points to make a ray. Then you have to start with the point, the exact same point, and go the other way. Remember, it takes 2 points to name a ray. So, opposite rays are two rays with one common endpoint. Two rays with one common endpoint and forms a line. That is the most important part of the entire definition. Yesterday we talked about what are two rays. Okay, we talked about what an endpoint was. We talked about what a line was. So it's mashing all those things together. Now, are we able to...
Teachers, for a minute, at this time, please release all juniors 8 through L to the pack. Thank you.
Any juniors A through L? Is that you? Peace. What am I going to tell you? Alright. If you get lost, we'll cover some of this stuff tomorrow too. Alright? So, the most oftenly missed quiz question right here. And you guys get really, really close to it, but you can't really nail it. So, can we name that blue ray right now? Or blue line? Do we have the ability to do that?
No.
Not yet. We need some what? We need some letters. So throw some letters up there. How about F, O, and X? Okay. So if I'm going to name a pair of opposite rays, they have to share a common endpoint. What is the only point they share that is common?
O.
They share point O. So both of my rays must start at O. One ray travels towards X. It's a trick question. The other ray starts at O and travels towards X. So I like to write them stacked like this when I write my opposite rays. That way I know they both start at O. One travels towards X, one travels towards O. A lot of you guys will mistakenly put that they'll try and say that those are opposite rays. And it makes sense what you're doing. One starts at F and goes towards X. One starts at X and goes towards F. But it makes one thing that doesn't happen. It doesn't fit they have a common endpoint. The endpoint of this ray is X, way over here. The endpoint of this one is F, way over here. Those two rays look like this. Do they start at the same spot?
No.
No. Okay. Another one that you guys may try and do are those opposite rays. Okay. Well, so they fit one part. They have a common endpoint. Ray IG starts here and goes towards G. Ray IB starts here and goes toward B. Common endpoint, but they don't form a line. That's where it gets weird. Okay? Probably the worst one today. Probably the worst one. That will be a quiz question. Guaranteed. Let me do one more. So when I add one letter in there, does it make more answers? Yeah. So now can you name me a pair of opposite rays in here? Okay, so you're going to say OT, like overtime. What am I looking for? Ray OT. So ray OT starts at O and goes towards T. And there is only one answer now. The opposite ray for ray OT. Ray OF. Okay. Now let's pick a different common point. Can you name another pair of opposite rays? Ray. Did that one. So I don't want to start at O anymore. Okay, so perfect. Now we can say ray TX starts at T and travels towards X, and then there's two different answers you can get for the second part. Ray TO or ray TF. They're both the same ray. Okay? Opposite rays, that's one we're gonna struggle with for a while, I promise you. Alright. Who knows how to read? Who wants to try and say that? What do you got? Colinear, or is it Colinear? It's colinear. Colinear. Colinear, not Colinear. So colinear is a really, really easy definition. Really, really easy definition. Two or more points on the same line. So the good part about this one is the answers are yes or no. You don't have to list anything. You don't have to name anything. It's just yes or no. So let me give you a diagram to yes or no off of. So yes or no. Are M, A, T, are points M, A, and T colinear? Yes. Why? They're on the same line. Are points M, A, and X colinear? Yes. Are points M, A, and H colinear? No. We have a really fancy word for that. What do you think it's called? Cheaters. Non-colinear. That's points not on the same line. So guess what? I'm going to skip that one. Okay? Now, like super complex question. Are points M and H colinear? Yes. What? Because any 2 points make a line. So M and H are on the same line. You just can't see it. They're on line MH. Are A and T colinear? Yeah. Are hippopotamus and smiley face colinear? Yes. Can't see them, but there's a line that connects them. The best one yesterday was, are your head and your pillow on the same line? Yeah, you know where your head is. You know where your pillow is, and there is a line that connects your head to your pillow. An express line right after school, right? So The notation is either yes or no. If I say to list collinear points, you would just say M, A, T, X. You would just list them with commas. So do you want a formal definition for non-collinear? Or you think they're good? Good? All right. What do you think this one is? Or how do you say it? Coplanar. Sounds like all of you guys in math. You're all coplanars, right? Oh, that's coplanar. So with coplanar, this is another one that's really, really weird. Right? What do you think it means?
They're on the same line.
Okay, they are on the same plane. Easy. But I have to make it super difficult. 3 or more non-collinear points on the same plane. That non-collinear thing is super important. Okay, and then you get to experience Baker's first mathematical drawing. And we'll talk about it for a hot minute and then we'll use it. So sometimes you'll see this. Your eyebrows like, what the hell did he just draw? Any idea what's going on there? Let me show you. This is one of my favorite things. BT dubs. There's always pencils up here if you need one. Okay. Don't be bougie and think you can't sharpen your own pencil. So, this white paper right here is like plain ABC. Okay? And then line XJ does this. So there's the third dimension. It looks like that. So the dotted line kind of denotes dimension. It's behind the plane. Y'all see what's going on there? So let me add some more points on here. Our points A, Z, B, and H collinear. I'm sorry, coplanar.
Yeah.
Yes.
A, B, Z, and H are coplanar. Our points A, B, C, and Z coplanar. Yes, I'll be very careful here. Our points X, B, and J coplanar.
Yes.
I have 2 yeses. I have 1 no. It's a no.
No.
Why? Why? Why am I wrong? Why are you wrong?
They're not on the same plane.
Because X, B, and J are collinear points. Unfortunately, X, B, and J are on every plane. You see that? They're on every plane. They're on like 1 million planes. They could be on this plane right here. They could be on this plane right here. They could be on every plane in the world. So they have to be non-collinear. Are A, X, and J coplanar points? That one's easy, right? AX and J. Yeah, they're on the same plane. Because how many points do you need to make a plane? Any three. So are J, H, and X coplanar? Don't even think. How many points did I say?
Yes.
3. Yes, the answer is yes. Are J, Clock, and Baker coplanar? Yeah, can't even see them, but there's 3 points. They're there. This is where it gets really weird. This is why I spent, I don't know, like 13 days creating this masterpiece. All right, so we're talking about coplanar points. This is a 3-dimensional representation. Can you read it? You see D, X, and C on the top of the box right there? What plane is that on? The top of the box or the front of the box? They're on both. They're on both. That's why they can't be collinear points. But you see C, H, and G. C, H, and G. Can I set this down? Here's C, here's H, here's G. What plane are they on? This one right here. Are they on this plane over here? No, only. All right, I'm about to do it. You ready? Good luck. Are B, A, and G down here. B, A, and G. See it? B, A, and G. Are they coplanar? What part of the box are they on? B, A, and G, way over here. What part of the box are they on? You're right. Yes, they are. How do you know you're right? I only said 3. And here's the issue. You guys can't see the plane. But what if I drew a diagonal plane through the middle of this box and cut the box in half? It would work, wouldn't it? So let me attempt to draw that for you. This is where it gets really fun for me. Have you ever drawn a box before? You know how to draw a box? So we're talking about this point. So this point, and this point right here. Are those 3 points coplanar? Yes, they are. And then if I draw the plane for you, you see this flat plane that cuts diagonally through the box. Now you can see it. So your first test question is going to be a question like that. It says name a set of coplanar points. And they give you 4 points. 4 of them. Is that okay? Can you have more than 3 coplanar points? When they give you 4, it becomes very, very specific. So if they give you this point, and this point, your 4th point has to be this other dot over here to make that diagonal plane. Does it make sense? If they gave you a 4th point over here, it wouldn't work. It'd be kind of off the sheet of paper kind of deal. So 3 or more, and the non-collinear part really screws you guys up. So just be careful with that one. What do you think non-coplanar is? Non-coplanar. Non-coplanar would be not on the same plane. So I got J, W, A, B, and G. Are J, W, A, B, and G coplanar points? Absolutely no. There's 4 on the front of the box, there's 1 on the back of the box. It's an absolute hard no, they are not on the same plane. So, non-coplanar. Okay, just going to talk about this one. We're not going to draw a lot of pictures. That might be on the inside of your notes on the next one. Or no, is it in the box? So an axiom or a postulate, is that in there?
Yeah.
is an assumption? Easy. Easy, right? I should clear it up. You should know everything about axioms and postulates now. So what's an assumption that you guys make every day? You know what an assumption is? So give me something that's an assumption. Put me on the spot. Here's an easy one. Next period, third period. Facts or assumptions? No, assumptions. Absolute assumptions. It's only a third period when you leave this class and you actually walk to third period. Then it becomes third period. When is it not third period? The last day of school, we have first period final, second period final, then you bounce and go home. So every day when you leave second period, is the next period third period? No. Generally, most of the time it is. You just assume you're going to walk to third period next. You could be going to an assembly. You could be going home. You could be getting checked out. You don't know it's third period, so you walk in there and do it. Here's a really, really popular assumption. I love you. Am I telling the truth? You have to assume I am, right? How do you know I love you? When I give you 2 points on your test. When I pass you for smiling every day. Right? You don't know what's going to happen until it actually happens. So that's what a postulate or an axiom is. It's just something that you assume to be true. Don't draw that. Don't waste your time. Just want to talk about it for a hot minute. What do you see there? 2 planes, right? What color are the 2 planes? White and gray. Does everybody see a white and gray plane? Cool. What else do you see there? Points? How many points do you see? A lot. Yes, sir.
It looks like two opposite rays.
It looks like 2 opposite rays. Can you point that out for everybody? What did I step into?
A to F looks like a ray.
I don't see A to F. That's not math.
Point A to.
No, that's just 2 points. Yeah, I love my job. Would you say they're opposite rays? So you start with ray, ray, ray. AF is what you saw? Let me find A. I don't see an A. Am I blind? Oh, that's a G. Sorry. Yeah. So GF is a ray, and then its opposite ray is GE. Crazy, right? You see anything else up there? G and J be a ray. Ray GJ does exist. It starts here and it goes down this way. What ray or what plane is ray GJ on? The gray plane-ish, right? Come on, get fancy with it. Plane R. Stop. Pause. What color is plane R? And she used that capital cursive letter to identify that plane. So let's build off of that one. Give me another name for plane R. Plane J, K, G. There's 1, 2, 3 points on the gray plane. Are they all in a straight line? No, so we can use those 3 points. So let's go with the other one. You said plane K, right? What color is plane K? White plane. Can you give me another name for the white plane or plane K? Go ahead.
L.
Why would that not work?
I don't know.
So remember the lowercase cursive letters don't talk about lines. So line L is this black line right here. Okay. So we're looking for just any 3 points on the white plane. Plane E, I, F would work because there are 3 points not in the same plane. That's on plane K. All right, so let's talk about this one. What is the intersection? Did we skip intersection? No. What is the intersection of the white plane and the gray plane? G. Did anybody think H? Did anybody think I? So if I force these two planes to cross each other, right? I got this front plane right here, and I got this top plane right here. Where do they intersect? Here, 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 here. What do you call all these points in a straight geometric figure? A line. Two planes always intersect at a line, not at a point. So I want you guys to feel those are some of the easier answers. I use that E word very, very like dangerously because they might ask you what plane is line EJ on? What's wrong?
No,
What plane is line EJ on? Silence. Do you see line EJ? I can draw it for you.
Oh, yes.
Is it on the white plane? Is it on the black plane? But does line EJ exist? It does. It is there. So those are some of those weirder ones. What about what plane are points E, I, and K on? I'm looking for what plane are E, I, and K on? You're gonna hate me when I tell you the answer. What plane are points E, I, and K
Can you use both capital letters?
on? No, because that's two different planes. How do you do that? They're on plane EIK. Why does that hurt your mind so much?
Because they're on two different planes.
No, they're on the same plane, but you just can't see it.
What?
What? How many points does it take to name a plane?
3.
3. How many points did I give you?
3.
So guess what plane they're on?
Yeah,
Plane EIK. You don't even need a picture. This is gonna be fun. You're lucky I'm giving you guys. Or should I take the picture away? Is that what's confusing you guys? No. It's crazy, right, guys? It's just absolutely just the most wonky math you've ever seen in your entire life. These are really important. So these are the last thing. We'll kind of speed through these real quick, and then we'll call it a day. All right. Postulate 1-1. This is something that I will harp on you guys over and over and over again. Postulate 1-1 is through any 2 points, there exists one line. Period. Now, we're calling that a postulate, and we said earlier, postulates and axioms are really what? Assumptions. You just have to believe that it's true. So it says there's point A and there's point B. Guess what? Line AB exists. Period. Here's point C and point D. What do you have to assume is true? Line CD is there. There's point F and point J. What exists? Line FJ. You can't see it, but it's there. So this is one of those things that geometry is built upon. If I ever give you 2 points, it is your job to assume that one line connects them. How do you feel about that one? Yes.
Are all of these gonna be on a quiz tomorrow?
All the vocabulary words will be on there. There'll be the term on the left, and there'll be a definition on the right. Yes,
We
sir.
can use notes, right?
It's an open notes quiz. You want to ask that louder so everybody else can hear you? It is an open notes quiz. Now, unfortunately, the test is not open notes. So I would encourage you guys to try it with the brain right here before you use the paper. Okay? Postulate 1-2. What do you think that one's saying? That's the intersection postulate. Let me write it down correctly for you. I always screw through the verbiage up on this one. Pretty good. If 2 lines intersect, they intersect at one point. Does that seem kind of like a duh thing? Or no? It does? And it's not supposed to be. Why would we take time and actually say that? How big is the point? It doesn't have a size. So if lines are made up of infinitely many points, and we have 2 things that have infinitely many points, and those 2 points have no size, how are you supposed to describe where they touch each other? Right? Like how many molecules are in my fingers, and how many times are all those molecules touching each other? Like a billion. So we have to say specifically, if 2 lines ever intersect, they only intersect at one point. And generally, that point will be labeled, those 2 lines intersect at point X. It's an easy one, but it carries a lot of weight with it. So 2 lines intersect at one point. This is an example of your first project. Right here. The actual sentence. It says, if 2 lines intersect, then they intersect at one point. That's called a conditional statement. You have to write 5 of those statements for your project, and you get 100. 5 sentences. We'll talk about that. All right. What does this one look like is going on? So that if 2 planes intersect, so this one's kind of the other one. If 2 planes intersect, they intersect at one line. So when the wall meets the ceiling, they intersect at that crack that goes all the way across the top of the room. They intersect at a line. So the same thing, if a line has no thickness, if a line is made up of infinitely many small points, how are you supposed to describe where they meet? So those two blue planes intersect at that one red line. And even it's not a line segment. The line doesn't start here and stop here. The line actually goes on forever because planes are infinitely wide and infinitely long. So this one's already written for you. Is it still there? So it says, through any 3 points, there is at least one plane. At least. So in this part right here, you see how all 3 points are in line. So these 3 points are on infinitely many planes. But I want you guys to put a star next to this one. Through any 3 non-collinear points, there is exactly one plane. So the 4 things that we're talking about, it takes 2 points to make a line. It takes 3 non-collinear points to make a, we've talked about that. Now we're just formalizing it. So we have, it takes 2 to make a line. It takes 3 non-collinear points to make a plane. The other one was the intersections. 2 lines intersect at one point. 2 planes intersect at one line. So those are all 4 things that we're talking about. At this point, I'm going to set you free. Right? You're going to see pictures like this on your assignment. Your assignment is dual purpose. It is for today and it is for tomorrow. So we're only looking at the front. Just try it. Right? I'm going to subtract a baker. I'm going to add a student and see what the result is. So it says, name a plane on the prism. You want to give a shot at that one? You're close. He said XAW. Can we fix it? Don't change the letters. Just add a word. Plane XAW. I didn't hear you. Sorry, my bad. Plane XAW. He said, what did I do wrong? Plane XAW. Y'all see that one? It's at the top of the box. If that's the way that you see the box laid out. Does that kind of make sense? They're super easy answers. Does plane Y, Z, X exist? Yeah. Does plane B, A, D exist? Yeah. The weird one is, does plane CXW exist? Yes. How many points did I give you?
3.
Yeah, CXW is there. Your brain just can't see it. It's there. That's that diagonal plane across the box. So then it says, you said plane XAW first, right? Name that same plane a different way. Plane AXW. Use the same 3 letters, just reorganize them. Alright? So it's easy for you guys to do this because you're writing on your paper, you assume you're right, and you move on. But then when you tell me the answer, I pick it apart. Alright? So I'm going to hand this to you guys. Once I give this paper to you, I'm going to ask you guys to take your name tins and put them back in the folder. If you want to glue your stuff in today, you can glue it in there. We're done writing on it. And then you have a few minutes, like 10 minutes, to start looking at this. It is front only. That's it. Just the front only. There are some questions on the back. The assignment really stops at number 25. Theoretically, when am I picking this up?